All right, number 45. We have a ball. It says freely falling object. We'll just make it a ball. It requires 1.5 seconds to travel the last 30 meters before it hits the ground. From what height above the ground did it fall? Now this is a problem where your diagram is going to be super important. Okay, so we're gonna label everything that we're given. So this kind of breaks into two parts. There's the first part of the fall, and then there's the second part of the fall. So right here, this line here represents the start of the second part. So here's the ball right there. The second part begins right there. We know that it takes 1.5 seconds. So the time for this region is 1.5 seconds. And I'm going to call that T2, meaning for part 2 of the fall. And then X2 is going to be 30 meters. Now, here's a problem where I would say it makes life easier to say that down is plus. You know what I'm saying? Did any of you do that? Just make down plus. It's going to make life much easier. Now, why can we do that? Well, at any point in this problem is the object going up. At no point is it going up. So let's just say that down is positive. It's going to make life nicer. Okay, so these are positive values, right? As the ball goes down for this second region, it travels 30 meters downward. We're saying down is positive. Now, what's the acceleration in region 2 as the ball falls? It's equal to gravity, which in this case is going to be 9.8. Positive, because we said down is positive. Okay, now, the velocity right here, right at the beginning of region 2, we don't have that velocity. Now, what should we call that velocity? Should we call it v final or should we call it v initial? Well, the answer is it's both. When would we be calling this v final? If we're focusing on region 1, when would it be v initial? If we're focusing on region 2. So look, that velocity connects the first part of the fall and the second part of the fall. Okay? Now, let's label the first part of the fall. The first part of the fall, what do we know? Do we know x1? Do we know how far it falls there to there? No, we don't have that. So that's a question mark. Do we have the time t1? No, that's a question mark. We have the acceleration. The acceleration is gravity, 9.8 meter per second squared. And then let's see what else. Oh, what's the initial velocity up here? 0. The ball starts at rest. Okay, so ultimately what they want us to find is the height above the ground that the ball fell from. Well, we already have this distance, which we called x2. That's 30 meters. So to figure out the total height, what we need to figure out is the first distance. Does that make sense? Okay, so here's how I did it. The first thing we got to do is we got to find this velocity right here. That's what I did. I found that velocity. Now, how did I find that velocity? I went like this. So to figure out this velocity right here, I went x equals 1/2 at squared plus v initial t. And if you look at this, we have everything, right? Except v initial, right? So it's v initial for the second part, right? So doing the algebra, v initial is going to be x minus 1/2 at squared over t. So v initial is going to be, so the x is 30. We're saying down is plus, so we can leave that as plus. Minus 1/2, the acceleration is plus. We said down is plus. And then the time we have is 1.5 seconds. And then divide this by 1.5. And we get the initial velocity for region 2 as 12.65 meter per second. Positive indicating downward again. All right, any questions with that? So we now know, so I'm going to take this and shrink it. So we now know what this velocity is right in between region 1 and region 2. So this is positive 12.65 meter per second. Okay, now one more calculation and we can get x1. So if you look at the same kinematic, x equals 1/2 at squared plus v initial t. What's the initial velocity for region 1? We're now focusing on the first part of the fall, region 1. What's the initial velocity? 0. So then we're just left with this, and we can solve for x1. So x1 is going to be 1/2. Wait a minute. Hold on. No, wrong equations, Paul. Back up. I won't say the word right now. What I just look like. Okay, try again. So we're solving for x1. Sorry, guys. So we're solving for x1. I wrote down the wrong. I even have it right here on my paper. The wrong. Okay, it's the correct equation that'll do it. Vf squared equals v initial squared plus 2ax. Okay. So v initial at the start of region 1, 0. So now we can solve for x1. This is x1 here. x1 is going to be vf squared over 2a. So v final, what's the final velocity for region 1? 12.65 squared, and then the acceleration's 9.8. So x1 comes out as 8.2 meters. So we now know the total height the ball was dropped from. 8.2 meters. So what's the total height here? 38.2.